third period, I need all of the seniors to meet in Mrs. Evans's room. All of the seniors at the start of third period. Thank you.
All right. What is this? Pre-cal, algebra 2, algebra 1. All right. How do you remember that?
Don't know.
Here from Mr. Mackey.
Neat handwriting. Look at that chickadee scratch. I think girls have neat handwriting, and I don't. Then this happens.
Hey, I can read one. I don't know about you.
You can. You can too, because you do. Okay, because of our limitations, and by that I mean for those who are not in class, they can't see what we would do on the whiteboard. Otherwise, I would have some of you come up and put your work on the whiteboard. Since we have to be under this camera, we can't really do that. So I'm going to work through these real quick, and you check your answers. And you'll be able to see my work. I'm going to be using pen, and the only reason why I'm using pen is pencil doesn't show up underneath this camera as well as pen does. You should always use pencil. So number 2, it was 104 equals y minus 67. These are one-step equations, one step away from the answer. It's the y that I need to get by itself. The minus 67 is over here with it, keeping it from being by itself, so I need to get rid of that minus 67 by doing the opposite. So plus 67 on both sides. And let's see, 201 equals y. That's not right. 171, sorry. 171 equals y. How come only Ms. Ham said something?
I was like, 200. Guys, y'all gotta say something.
Yeah. Okay, number 4. Negative 4 plus t equals negative 7. I need to get the t by itself. It's this negative 4 that's keeping it from being by itself, so I'm going to do the opposite. So plus 4 t equals negative 3. Number 6. Negative 6 plus c equals 32. This is exactly the same problem, only different numbers and variables. The c needs to be by itself. It's over here with the minus 6, so plus 6 plus 6. C equals 38. Number 8. 3 plus g equals 1 over 4. Just for giggles, can you tell me another way to write 1 over 4? Close. 0.25. That may be easier for some of you to think of this as 0.25. All right, the 3 is over here with the g, so the 3 needs to go. It's plus 3, so minus 3. Minus 3. G equals negative 2 3/4. Or negative 2.75. Now in the calculator, you would do this exactly the way that it looks. 1 being divided by 4, take away 3. But when you go plug in 1 being divided by 4, be sure and put it in parentheses. That's the easiest way to put a fraction in a calculator. So 1 divided by 4 minus 3 negative 2.75. Now, what do you do if you need to have that as a fraction?
Math. Insert.
Math, enter. That changes it to an improper fraction. If now you wanted that to be a mixed number, you go to alpha y equals, and option number 3. The numerator, denominator, that form, change it to a mixed number. Let's see if it'll work. Yeah. Are you all right there, Eve? All right, that was 8. Number 10. Yes, finally. We get something with a little meat on it. T being divided by 7 equals negative 5. Since the 7 is being used to divide with, the opposite of that is multiply. So I'm going to do this side times 7 and this side times 7. That turns this into a 1. So T equals negative 35. Number 12, 2/3 n equals 10. The 2/3 is being used to multiply with since it's right next to the n. And the opposite of multiplying is dividing. So divide by 2/3. divide by 2 over 3. This is the one where if you're working it out, showing your steps, you're going to have one more step. When you're dividing by a fraction, what do you do? Flip it upside down and multiply. So it's 10 over 1 times 3 over 2. 10 times 3 is 30. 1 times 2 is 2. And that equals 15. And then finally, number 14. 12 equals x over negative 3. Here's the x. I need to get it by itself. It's on top of a fraction, so I need to get rid of the bottom of the fraction. The negative 3 is being used to divide with, and the opposite of that is multiply. So times negative 3 on this side, times negative 3 on this side, negative 36 equals x. Now, before I ask for any questions, let me point out that sometimes we had the variable on the left-hand side, sometimes we had the variable on the right-hand side. It doesn't make any difference. And in fact, if you're the type that you've always got to see it on the left-hand side, then it's okay to take these equations and just flip them, as long as you don't change any signs. So the one that we just got through doing, if I've just got to have my x's on the left-hand side, this equal sign means it's the same on this side as it is on that side. So I'm not changing anything about the equation if I flip it around and write everything exactly the way that it was before. So you can always do that. And for some people, it's less confusing that way. I don't know. All right, any questions about these? No? One-step equations. Great. Because now, multi-step equations. Yes! Yes! Woo! Ain't nothing gonna get you going in the morning like a good old multi-step equation. Say it with me, Alyssa. Yeehaw! Come on. Come on, Alyssa. Yeehaw! If you will, Ethan will. Yeehaw!
Yeah, I don't think no.
Say it.
You have to give an idiot to do it.
Yes, he said 3.
We're going to do multi-step equations, and then they'll give us equations with variables on both sides, and eventually we'll get to equations using more than one variable that we'll have to solve for. But it's nothing that you can't do. In fact, you've probably even seen this before. You've probably even practiced this before. But 99% of the time, solving multi-step equations is going to involve nothing more than our 3 steps that I have written on the board right over here. 99% of the time. Sometimes they'll change it up a little bit and we'll have to do something else before we can finish those 3 steps. For Algebra 1, multi-step generally means there are 2 operations that you're going to have to do. We just got through with these exercises where there was just one math operation to do and bam, you had the answer. It's not a huge step to go now to multi-step where you're probably going to have 2 things that you have to do. I'm just going to give you an example. Our goal in solving any equation is to get the variable by itself on one side of the equal sign, and the other side of the equal sign, we just need that to be reduced as far as we can reduce it. Sometimes that means that we end up with just a constant, just a number, and sometimes it will be an algebraic expression. For now, it's just going to be a number, a constant. So our goal in solving this is to get x equals nothing with the x and just a number over on the other side. Now for the last 3 or 4 years, you've been told you have to follow PEMDAS, the order of operations. I need you to hear this. You have to follow PEMDAS, the order of operations. And that is 100% correct. But PEMDAS doesn't solve equations. PEMDAS simplifies expressions. So if there were still math to do on the left-hand side, we would follow PEMDAS, the order of operations, to completely simplify this side. If there were still math to do on this side, we would follow PEMDAS to finish the math on this side. Once both sides of the equation are simplified, there's no more math to do on the left, there's no more math to do on the right, then it's time for us to start moving things to the left and the right. When you're solving an equation, most of the time you will work PEMDAS backwards. There are a few exceptions. For example, in this equation, here's the x. I have a 2 being multiplied to it, so I have multiplication. I have the 17 being added to it, so I have addition. Which operation do I do first? Which one of these will I undo first in solving this? The one that you would do first is the addition. Now there's a reason for that. It saves you steps. So I'm working PEMDAS backwards, and when I work it backwards, it tells me addition is going to come before multiplication. So I'm going to take care of this addition first. I'm going to subtract 17 from this side. Oop, I almost did 77. That's a 17. Okay, let's pretend like Gage wrote it. And I'm going to subtract 17 from this side. And that leaves me with 2x equals negative 13. I got the addition part taken care of, and now it's time to take care of the multiplication part. 2 times x. The opposite of that is divide. Divide. 2 divided by 2 is 1. So I end up with 1x equals negative 6.5. Now you're not going to have to write PEMDAS at the top of your paper. I did this because I want to imprint in your mind when you're solving multi-step equations, 99% of the time you're going to start with whatever's being added or subtracted and take care of that first. Then you'll move on to whatever is being multiplied or divided. It would still work if we took care of the multiplication first. Here's why we don't. 2x plus 17 equals 4. If I want to take care of the division first, I have to divide both sides, which means everything on both sides. So 2 divided by 2 is 1. I end up with x. 17 divided by 2 is 8.5. And 4 divided by 2 is 2. And now I can take care of my subtraction. Minus 8.5 minus 8.5 x equals negative 6.5. Well, that just all of a sudden involved not extremely hard math, but it made the process a little bit more difficult. I ended up having to divide 1, 2, 3 times. I ended up with decimals, and we don't like decimals. This is a much more efficient way to do it. So when you're solving multi-step equations, first look for the things that are being added or subtracted. Take care of those first if you can. Then do the divide and multiply. All right, that's like example number 1 that they gave us right here. First, they had minus 4, so they added 4 to both sides. Here's the result. The 11 was being multiplied to the x, so they divided both sides by 11. And then here's the answer. X equals 3. The exception to the rule of doing add subtract first is when somehow you've got that add and subtract locked up. It can be locked up by a fraction, or it can be locked up by parentheses with a number on the outside of the parentheses. In that case, you have to do those operations first. But that doesn't mean they have to be any more difficult. I know you can follow along in the book, so let's do one where we have to use our brain. X minus 2 being divided by 10 equals 1. Here's one of the scenarios where I want to start with this subtraction here, but it's locked up. It's on the top of a fraction. Are you watching, Bailey? So I've got to get rid of the fraction first. The only way I can get rid of the fraction is take care of this 10 first. It's being used to divide with. So what do we do with the 10? Multiply with it. So this whole side times 10. This whole side times 10. Ten divided by 10 is 1. So we have 1 x minus 2. 1 times 10 is 10. And now we have something that we like a whole lot better. What's the last operation to do? Add 2. X equals 12. It can be. Now here's the other way that your addition or subtraction will be locked in and you'll have to do something else first. If you have parentheses, 4 parenthesis x plus 3 equals 12. We're doing multi-step equations. We get to this problem. Here's an addition. We want to take care of it first, but it's locked in on the inside of the parentheses. It's locked in by this times 4 out here. It's times 4. The opposite of times 4 is divide by 4. Divide by 4. I'm dividing the entire left-hand side by 4. I'm dividing the entire right-hand side by 4. Yes?
You wouldn't distribute first?
No.
Not on these?
That's adding another step. You would have each of these increase by a factor of 4. And so you would have to divide 4 out anyway, and it would turn it right back into that.
Yes, sir.
Yeah.
Just, I was double checking because I'm like, wait a minute.
Yeah.
Thank you.
This is all one number. And we're dividing it by 4. And what this does is it takes that 4 away. It makes it 1. X plus 3. There's nothing on the outside of the parentheses now. The parentheses are gone. Bailey, I need you to stay with me. And on the right-hand side, 12 divided by 4 is 3. And now what? Subtract 3 on both sides. X equals 0. So those are the two situations where you would not start with add and subtract. If your add and subtract are not locked in by parentheses or a division, then do them first. All right. Here we go. Page 93. On number 1, which operation would you do first? You have multiply and add. You take care of the addition first. How about on number 2? You take care of this subtraction first. It's not being locked in by anything. Number 3? Yeah, you take care of the plus 2 first. It's not a part of this right here. Ooh, how about number 4?
Subtract.
Yeah, take care of the subtract. It's not being locked in. Number 5?
Division.
Yeah, you got to take care of that division first because this one does have the subtraction locked up. And what about number 6? Division. All right, so why don't you do 1 through 6 for me?
Is it the first day of October?
Step by step, it is. And I'm going to leave these up here.
First day of October.